You have to hold it.
My doctor does that. Okay.
All right, so we're design team 2007, and we are working with the tamper-resistant device for our crippling surgical central catheter. So we had came up with the problem, or we were given the problem was for an outpatient setting, there are people that have, say, a drug addiction or have problems with drug abuse in the past. We then had to create a device that would, or a casing that would cover that catheter injection ports. Each of these two ports right here. So we had to come up with a casing to cover those to then make sure that they wouldn't get into it if we were to send them home with this catheter. Normal people without this, without a drug addiction, can be sent home with their catheters, no problems. They just get it basically taped up into a dressing basically, and go home and then come back, say the next day or the next few days, and then they would get administered their medication or their therapy for whatever they're getting done, and they don't have that issue. So, moving on to the mechanical design. So we came up with our casing initially. This one's actually kind of big. I don't know if you guys want to look at it. These were our initial designs because we thought we had a lot more circuitry that we had to fit inside of it. So we kind of came up with a larger design to make sure that we could fit all the circuitry into it to begin with. That being said, that's why it is quite large, and if you do put it on your arm, it's going to be kind of an issue and kind of blocky. So we've also, taken that into consideration, and we've changed a lot of things in our design so far. The design that's up there right now is a more updated version, which is about relatively probably closer to this design. This was our first one, but we noticed we needed more electrical stuff, so we made it bigger just to make kind of overcompensate and make sure we can fit everything in our design. So it's probably about 1.5 or 1.25 times the size of this one, and being that set on your arm is a little nicer, and having those brackets probably just makes it a little larger, about 0.25 inches in each direction.
And do we have a material of construction for that?
We're going to go over that next, but yes, we do. We have come down to some materials that we did look through, and Tyler will talk about that. As far as kind of the design I went over, I basically made a couple extrusions to keep from the shaking in the design. The brackets here are both for the elastic strap that will go around your arm to both secure the device and keep it from moving and catheter from pulling out. And then I think that's good. Here's a little motion study of how the locking mechanism will work. I don't know why there's a black screen, but it kind of shows here this would be our linear actuator that would go and lock the two halves together.
How do you unlock it?
That'll be done through our device and the electronics that we have inside, which we'll go over pretty soon here.
Bluetooth with a phone, like everything else, right?
So we decided that our casing was going to be made from polycarbonate because it is a hard material and it's also transparent. I did some hardness testing with the Rockwell hardness tester in the design shop. And after a couple of trials using a 15-loop load, we got a value of 69. And when you look at the graph in the middle, you can see that our hardness is comparable to cast iron and aluminum.
So do you really think you have 4 significant digits in that average?
That's not.
Please stop doing that. I corrected a couple people at the thing on Friday. When you write numbers, write them to a reasonable number of significant digits.
Yeah, so you can see like there's different sized indentions on that. The middle sized ones I used with a 15-loop load, 1/8 inch ballpoint diameter, and the small ones are diamond point to replicate like the size of a needle.
You're not going to be able to RP it with polycarbonate. Is this just going to be a cover? Or?
You actually can print polycarbonate in our not in our 3D printers, but they do have, they can
The
help
higher
write
one.
3D.
And our PC, they can.
No.
I don't know if they can there, but, we did kind of go through and look for places that can print polycarbonate.
Yeah, you can drop it out.
I have a friend of mine who works at Rexner who's offered to help print our final casing once we get the material done.
And is it relatively clear too when it comes out? Or-
Yeah.
It's 90% light emits through.
That's sweet.
For tampering, it might be gonna be okay.
Yes.
Yeah, that's what I'm thinking.
It was more so for the whole monitoring, because if we were to have like, the ports in there, and I guess, I mean, if you can see it, if you can't get into it, that would be a good thing, and if you can't see what's in there, that's also a good thing, but, for the site, a healthcare professional that would need to see into it, and make sure that there's nothing going wrong, there's no like, fractures or anything that's causing it to leak, or, say something's pulling up in our device and no one's ever gonna know. And I guess it's gonna be checked every now and then, but also I think having that kind of transparent material allows for them, not for the patient, but for any healthcare professional to see inside of it.
Here, we tried.
Maybe not the electronic
Last
side.
week, I heard something on NPR or something, people that have to go through long courses of antibiotics, since they were doing something previously, they're drug addicts, they have to stay in the hospital. It's a huge healthcare cost. And they work in the appliances work because they leave,
Yeah, it's mostly antibiotics and then chemotherapy, so they don't have to keep injecting into the same vein, it'll shrink up. So just having that port for them to come back, get their treatment, have it injected without every time they come in having to do the new catheter each time. And then also, if people are having digestive problems where they can't take the nutrients in, they have liquid nutrition, you can also inject through the port.
And for our circuits, I've been working on the circuits along with Martin and Kiki, who are working with the Bluetooth code to try and get a circuit where the Bluetooth chip will control the motor using a PWM wave, which will turn the motor one way or another. So we need a linear actuator to extrude or pull back to lock the device, but we're using a motor which we will modify with a metal rod to actuate for us, because the linear actuators that were really small for our application were not only expensive, but they also needed high voltage current draws, because the motors are very low current and only need 3.3 volts. And so we have the circuit set up right now, which I will show you after our presentation. We have an LED with a resistor going to ground. We have a motor which is powered from the 3.3 volts from the Bluetooth board, and the PWM from one of the analog pins will control which direction that the motor turns. And thank you, Dr. Fenigo, because he's been very helpful with this part of the project.
You were able to get enough current out of the board to run the machine?
Did you do that based on a rating of the board or just wire it up and see what it did?
We did a couple of tests. I originally did the test wrong, so we had a few different configurations with driver circuits that we were using and some transistor circuits that we had drawn up, because I measured the current that the motor was using wrong, like very much so.
Magnitude.
It uses 6 milliamps. I was measuring like 700 or something like that. So the board is rated 500 milliamps and it only pulls 6 milliamps. So I didn't actually test how much output the board puts out, to answer your question.
So then I worked on the actual Arduino code for the NRF 52832. And so the code that I came up with interfaces with Martin's app that he designed, and we'll talk about. But basically what my code did was defining all the pins that we were using, the PWM for the LED and the motor that we were driving. And then after that, we connected to Bluetooth using a basic BLE UART example that Arduino offered to connect with peripheral devices. Once we got that to work, we worked with Dr. Tritt and tried to get the Bluetooth data recognized through the board and the app. So that we created a basic if statement saying if the data that the button sends is true, then the light turns off for an unlocked position and moves from max to min. And then if the button pressed, the button lock pressed is true, then the LED will turn on indicating that the device is locked and it'll move from min to max position locking the device.
Can I throw a couple of comments in? And this is, you know, for your, maybe make a note of this and then see if you want to integrate it into your design later. Do you think you really need lock and unlock buttons, 2 buttons, or do you think 1 button would be
We
suffice?
could do a lock and unlock button, and then just have the toggle. I think one of the reasons that we wanted to do 2 buttons specifically was so in that way a healthcare professional doesn't get confused and like go to press like lock or unlock and actually like unlock it when they meant to lock it type of thing. Like it was already locked and then they went and pressed the lock button again to say they forgot. We also have thought of the status, so right now I have a status that keeps track of what position that it's at, so I'd be a way around that. That was the original purpose of having the buttons.
I think a better design would be to have 1 button with an indicator, right?
I was
Because
just gonna
that's,
say,
yeah,
if there
it's
should be
usually-
just an indicator that it's locked.
Yeah, and that ideally would have been something in your specifications going in, you know, what your user, not specifications, what do you call them, the user requirements, right? Because the user would have told you that. I think as you think it through, you think, well, what's going to work better? So it's fine to add that now. The other one is the motor position or the lock position. It's kind of coming back to having an indicator there too. Is how do you know when to stop your motor from running? Does it just stall out at the 2 extremes, or do you
we-
assume that it moved? And
We have a for loop that goes through, and it basically goes through from the minimum position to the maximum position, and then stops at that position.
It steps a certain amount, so.
so you were doing a stepper motor in there, or what kind of motor are
I
you?
believe so. It's, I'm pretty sure that we changed the step size and it will change, like, right now it's, I think, on 3 steps with our code, so when we, show you the demo, it will, like, you'll hear 3 little, like, sprinkler noises,
Okay.
kind of, and you'll know, that when it hits the last one, and then we can measure, in the max, we can actually just measure the, distance, so we know how far the rod will extrude.
Okay, so is that a linear actuator or a?
No, it's
No, it's just a motor, but we'll attach a rod to it,
Tiny servo.
Yeah, it's
Yeah.
and it's very small.
We're turning it into a
Oh,
linear
yeah,
actuator.
So we'll make sure.
So again, it does come back to the idea though, is are you going to use some sort of positive feedback, either electronically or mechanically, that says when the processor told it to lock, that you detect the fact that the pin has reached the end of its travel, or did you just send a signal that said lock me? You know, those are 2 very different outcomes, and I think that's pretty important to your user in terms of which of those.
So just open the loop now, right, give it like 3 pulses.
You know, there could be a course called Controls where you can kind of learn about feedback. Nah, that would be
Right.
We think this would be better.
bad.
Somewhat of it.
That's a good point though, getting a sensor to make sure that the lock is actually in place, because right now in our loop, or in our if statement, it's just doing these 2 different actions, and the light's indicating that it is locked, but that's a different,
It'd be a real
blend.
easy thing to incorporate,
Yeah.
either optically or just a mechanical, really optical.
And I'm raising these issues now because when you do senior design show, you don't want the people coming around saying this stuff to you and, well, we never thought of that. So now you can say, well, we thought of that, we tried, but it was too hard to do, so we decided not to do it. That's a better answer, honestly, than we just didn't think about it.
yeah.
Thank you. So as Casey kind of mentioned, or on the app, so the left screen, as you can see, that's the first one, which is the connection. So when you're first connecting to a Bluetooth device, there's going to be 2 different like statuses. So like this one says right here, unknown. This one originally will say unknown, but then a list of all the different Bluetooth devices that are within the range of your, like in this instance, my phone, it picks up, and then you have a selection so you can pick up, and then from there it'll connect to it, and then you have to select the service. Once the service, and then it's also connected to the Bluetooth device, you'll switch to this screen, so in that way it's not confusing. And then it's just the unlock and lock button, which we could simplify down. And then this right here will be the status. It turns green, and then it also says that it's locked when technically right now it's just when you press and hold the lock button, this switches. So like you said, there would be a way that we could set up a sensor that would actually sense when it gets to lock position. that would be more effective. But essentially that's what the app does. And then if it gets disconnected for any reason from the Bluetooth device, it jumps back to this screen to the healthcare professional to reconnect.
And this is using the MIT
Software. Yeah, currently it's at that phase. Next quarter, I'd like to start trying to switch over to like Simulink.
Yeah.
That sounds like a better interface.
Did you ever get in touch with Master Lock? That's kind of what we were suggesting that.
Sent them a couple of feelers and didn't get anything
Didn't
back.
really bite.
Yeah, I guess I can kind of demo the app really quick. So I hit scan again. So basically up there on the top, there's that blue button that says scan again. So if the device doesn't pop up, then I can hit that, and then I can select the device. So then that will pop up saying that we're now connected, and we need to port team 2007. And then from there, services. Something else I'd like to do is kind of limit this so it's more user-friendly for the healthcare professional, because they're not going to know what these are, but we have to click this one. And then from there, then we have the lock and unlock buttons. When I unlock it, I'll turn off this light, and then the servo motor, this little thing should move over to this side.
Oh, okay. there we
And then
go.
we'll have this rod ideally connected to here. It kind of slides in those little holes, and then we can lock it in. And that's how we made it into a linear actuator.
Yeah.
Yeah, and then the lock turns on the light, and then moves some
Only like
Yeah.
$7, not $150.
We're gonna work to make
So
it
is-
more continuous too.
Is this a model airplane part?
It's
or-
RC.
Yeah,
I think
yeah,
it's
yeah,
RC
RC
cars, yeah.
stuff, yeah.
Okay.
It's from Horizon.
So see, I think we should use
That's,
more RC
that's
car
actually the
parts and-
Chinese part, not the
As well, they
Horizon
don't have to
one.
reverse the polarity on the motor to change direction, which is what I originally thought.
Yeah, that's what we were originally trying to figure out.
And it's doing all through the PWM.
You change the
Oh,
duty
so this is
cycle.
one where the position is the duty cycle of the PWM?
Yeah,
correct,
Okay,
yeah.
When you have to send truth license?
We
Oh.
actually were able to adjust it, so we could send a few different ones. It's basically the interval in which we stepped our for loop. So I think originally we had like 5 steps, and then we were like, we can make it faster, so we just bumped it up to 3.
Yeah.
I'd like the data sheet on that, if one of you could email me the, or I mean,
The data
I
sheet on
think it was
this?
on the
pretty
motor, or is it just
simplistic,
like
'cause
where
it
you
was
got
a-
it?
I think
What
it was a
catalog?
China part, so like it had very like.
Is China Part's the name of the company you're getting?
No, it was like a part from China, I believe.
have
and
the
then
Horizon
like
one
it didn't
too, I
have a
think.
lot of
Yeah.
Horizon
specifications.
Hobby
It had like
store.
basic ones like the voltage. It didn't even specify the current that it took.
Yeah.
So
Yeah.
But you could
Yeah,
create a
we're-
little light beam with an LED, a detector.
That's what we had originally, like kind of like a garage door we thought of.
It's little-
Sure, I can break this.
Actually, I don't believe you could. We bent wire cutters trying to like cut it. It kept on breaking the metal. I mean, you can bend it. We've been able to do that, but to cut it, that was very difficult.
It broke the wire.
But obviously,
Yeah.
Really? What is it?
They have
It's
pictures.
stainless steel.
Dr. Fenegal gave it to us.
But you can't.
I just had it laying around in my dump.
Did you take pictures of it or no?
You put wire?
I know
yeah.
one of us did, but
When you put like steel bike cables, you need a special part. Really heavy.
yeah, we tried using the wire strippers originally, and then it kind of like messed up the cutter part on that. So we went and actually got like dedicated wire cutters, and then like basically you know when you have like scissors and you try to cut like cardboard or something, like it
Yeah.
bends the scissors and it just slips in between.
And
They did that a couple
They
times.
come much thicker than that too, so you don't take
yeah,
it.
that's what
Right.
we were probably going to go to something thicker. It would also keep the stability of the case way better.
Yeah.
Just having like a piece of like lead rod in there is going to be pretty wobbly and create a lot of movement, which we don't want to happen because it'll allow it to get into
The other thing is, I mean, if we're worried about this, we also have to worry about our little plastic
Yeah.
piece here.
Yeah.
That's probably going to break before
Although,
this.
again, if
maybe.
you're clever with your mechanical engineering, right, if this is going through, you know, if you have 2 pieces slide together and this is locking those
Yep.
together, that's gonna be hard to open. And particularly if you have the back side kind of hooking under something and the forward side being locked.
That's essentially what we're doing,
You know,
yeah.
you might be
The
surprised
shear
how,
strength is obscene.
yeah, you might be surprised how robust, and then it's not gonna put, if they're trying to shear it here,
It's not
it's
gonna
not gonna put any force
on
on
the-
that.
like you can get a chainsaw and break it.
Yeah. Which I guess one thing you should do is, what if the battery dies? What, have you considered the failure mode of, they've got this thing locked on the person's arm,
No, they
and
need
now
it.
it's not working, it's not unlocking.
So I was gonna work on next quarter getting an indicator light for when the battery's running low, so that they can charge it and know.
Yeah, but and I agree
Like,
with
let's say
that,
it
but I'm
just
saying from
fails,
a safety standpoint, if I'm having this thing wrapped on my arm, I want an absolute fail-safe of a special key or
Yeah.
procedure, something thought through ahead of time, so that when you walk in and it doesn't come off, they're not looking at each other. You don't want the healthcare professionals kind of looking, well, now what do we do?
Right.
You know, you
Yeah.
want them to have, okay, we
Got the
draw
lines, put new ones on.
Well,
I
yeah,
think
and again,
that-
maybe they can do that, but what's a reasonable response from the healthcare person?
I've kind of thought about that, and that's kind of the conclusion I feel like would be almost, maybe not best, but the point of this is to make it like secure. So if we have a fail-safe that someone can figure out, that might make it just that much easier to get into.
But at least think it through and have it
Yeah.
in your documentation. We thought it through, and this is what we're going to do if this happens.
No, that's fair, absolutely.
You know, amputate their arm is probably
Not the,
Yeah.
yeah.
There's prosthetics.
Is it 3.7 volt lithium ion?
Yes.
Yeah, it's a 3.7 volt and then a 500 milliamp.
The motors that we got said they would run between 3.2, 4.2 volts.
Okay.
Optimal at 3.7, but 3.3 works.
And your Arduino works? Oh, it's a 3.3.
Yeah, just right off the pin on the board, 3.3.
And what is this? This is an Arduino with a Bluetooth and
Yeah.
piggyback?
And then for spacing, we would just stack the Bluetooth or the battery on top of the Bluetooth, try and optimize spacing and like try and tuck these wires down.
Okay.
And then, I mean, there wouldn't be all these big wires here. Just have the motor then and the light.
You make a little.
Yeah, I've made like 4 and I made them all wrong. I had them all upside down,
It's usual. That's good.
but I have attempted it.
That's okay. I mean, you learn by doing this. So
Yeah.
that's the reality. I didn't realize apparently there was a screw up on the USB-C on the Raspberry Pi 4.
Yeah, that's what
They
I
blew a
thought.
resistor. They had a resistor. They took the resistor off, and now it doesn't. If you plug in anything but a dumb USB charger, it doesn't work.
I thought originally, a long time ago, we think that was gonna be too simple.
Well,
Like, but it's coming together kind of.
I think it's coming together perfectly.
Yeah, I think so, too.
I think so.
We worked a lot with the, also next step in the case, we kind of have to go through all the ergonomics with it, because having something like this on there is, kind of like having like a house arrest block on your ankle, so.
It's not so bad.
Something else that we kind of talked about to make this just a little bit more comfortable is having like a curved design on the bottom so it like kind of contours
Yeah.
more to your arm.
Yeah.
It's also, it's on our new design, I don't know if you
And
could be able to
edges.
see it, but it's very slight because there is a bottom to this case, so you can't cut into the
You don't want
the casing
material.
floor, so if we cut into that, it's kind of, we'd have to raise this bottom casing floor up a little higher to then fit around that. So,
And the arm's not that extreme.
no, yeah, that's why it's only like, I think, I made it like a tenth of an, or like fifth, or almost a little under a quarter, I think, of an inch in a curve, setting all the way across.
Could you integrate, so on the one you have like the outrigger things for the strap to go through?
Yeah.
Could you reverse that so that you have, I mean, I've got some things that have like a slot through it, so rather than having the wings stick out, you actually have the slot
Yeah, like
integrated
that one.
into the case.
Yeah. That's what we also thought, because this does add like a half inch on each side,
Mhm.
which we thought that's gonna make, you know, on someone's arm, it's gonna be flapping out like wings. So
Mhm.
I did cut them down for now, but that's also a good idea to put like maybe a couple inlets in the bottom to just slide the
Yeah.
elastic strap.
Since you're
which
doing
is-
3D printing, it
Yeah.
should be okay.
Yeah, that's just the thing with the supports. They got to figure out a way to print it straight, so the quality is garbage and it won't fail midway through. So
Did you guys do the 3D printing in 1005?
No.
No, they
Right
didn't.
over there.
That would be this. Well, no, we're talking about the course one. That's so we added it after they took the course.
That's
You
it.
guys are running
Yeah.
printing these.
Yeah, and now half the students come in having already done it. It's moved so fast.
I had a 3D printer in my apartment for a while, so I knew how to kind of mess with this stuff and get a relatively calm print before. So, and it's really not that bad. But
Do you think
Yeah.
are students specializing at all? I mean, because frankly, you guys have so many different things to know. We had somebody in here last time with the Linux background, and somebody else does the 3D printing. You know, it would seem natural to me that for your generation of college students, you would start almost having to specialize, because you can't know 3D printing and Linux and security and electronics and
I think that's what kind of made the design team better is people who are specialized in certain things that kind of create our diversity that gave us like a better outcome in the end.
and then the mechanical skills.
It was kind of cool when everything kind of came together the last couple of weeks, because I know I was working on the app and Kirsty was working on the coding for the Bluetooth chip, and then Jay got the servo motor working, and then Colin had the casing, and like Tyler was testing materials, and honestly all just kind of came together in the last couple of weeks where we were able to kind of put it all into one working.
It took a while for me to get the motor to turn because I was using these benchtop ones. I tried like the one over there, and then I didn't get it to work, so I tried a different one, but I think for like a week or two. But it turns out that the duty cycle is too low for these wave jams to actually get under 20%. They only go down to 20%, so I need it to be lower in order to control it. So it would just like make a ringing noise when you plugged in the power, but it would never move. And we were actually considering buying different parts because we thought that this was faulty, but then we decided to try. I brought my embed board in and tried embed code. That I just dug around on forums to try and find some servo control code, and I found one that actually worked. It just moved it back and forth continuously.
So how low is the duty cycle?
Right now, I think you change it
It's
to
like 8%.
yeah,
Okay.
and you just
Around 8.
and you like change it right to kind of different measurement.
This technically I've changed a little bit, I remember that for
Oh yeah, we did
So
change
that
it.
should dramatically extend the battery life too, being
And I think that's why they did that. It's a really weird protocol. And it's actually, we're saying, and you can use pulse width modulation, but it's actually something like, maybe it's 1 hertz, and then it's gotta be, it's the duration of the high time. It's a really weird signal. And yeah, it's a small duty cycle, again, probably because they wanna not drain the battery on the RC car or RC plane or whatever. It's a standardized thing out there.
so much resolution for the pulse too.
Well, I think there's actually closed loop feedback. I mean, they're very sophisticated for being cheap little cars.
There is a chip on the bottom of it. I'm not 100% sure.
Yeah. I've got some references. I think you've probably already gotten past where you need to be. I thought that was in 2905 or 3205.
It might have been.
I think I mentioned it. I know I researched it while your section was going.
I would have to pull my notes back up.
It'll be there this quarter.
All right.
Good job.
Thank you guys. Good job.
Thank you.
Test print tomorrow.
Oh, phone.
Yeah.